Now we are looking at correlation between variables. Correlation, I don't know if you're aware of what correlation is. If someone was to ask you what is correlation, what would you tell them?
Correlation is the relationship that exists between two data sets. Basically, it's determining whether there is a relationship between a data set and another.
I agree with you. Although I would say it's looking at whether there's a relationship between one thing or another. But a very more layman way to put it is you're just checking whether two things move together. When one thing is moving up, does the other one also move up? And another one is going down, does it also go down? Or even the opposite, when one is going up, does the other one go down? Or when one is going down, does the other one go up? That's correlation. Now, in statistics, there are different kinds of correlations. The most common one, the one that's even used to analyze a lot, even in SPSS, something known as Pearson's correlation. Okay. And then when you're doing Pearson's, in some books, it's normally written as Pearson's R correlation. The letter R. The letter R is normally the value that when you run that correlation, it normally generates a particular value. Okay. And that value is what you read or you interpret as the relationship that you're looking for. Okay. That R value normally ranges between -1 and +1. That's another thing you should know. So technically speaking, if you're running an analysis and you generate a value of R that is either greater than 1 or less than -1, and just know there's something wrong somewhere that you've done, or your values are just not right, the values that you're working with.
All right.
So when you look at your data, given what it is that you've been given, the variables you have, which one do you think is appropriate to run a correlation?
Gender and height or gender and weight?
Really? That's correct. You can, let me not deny that. So you can correlate gender and height or gender and weight. But let me say a more meaningful one or specific one to check for is between height and weight. Height and weight are the same kinds of data. Okay.
Oh, I see what you mean.
You get what I mean? Yeah.
The values for gender are not, they don't vary, basically.
So you see, gender is just 1 and 2, male and female. But height and weight are still, they're like based on an interval that is more, there's data that is technically speaking the same. So even if it's not this data we are dealing with, if it was a different set of data, that is very crucial for you to consider when you're analyzing. What kind of data am I dealing with? Is it scale or is it just this other nominal kind of data? So it's preferable if you're correlating or checking the relationship between two variables that you have the same kind of data. It's not a must, but it's preferable. Okay. You can still correlate gender and height or weight, and we'll do that and we'll see. But for now, I'll just begin with height and weight. The other thing before we run that you should consider is, you see the ID, as in that represents the respondent. So the first respondent, 1, their height is 64 and their weight is 128. The second one, their height is 66 and their weight is 124. So what we are correlating, I need you to understand, we are correlating 64 and 128. Correlating 66 and 124. Okay. We are correlating the data respective to the respondent. We are not correlating 64 and 116. Okay. Correlation is happening respective to the correspondent. So the other thing I also want to just highlight before we do is, remember we had missing data, right? So when you're running a correlation, you don't need to be concerned about the missing values. SPSS will just ignore. Okay. There's something that's missing, it will just ignore. So to correlate, you go to analyze.
If we had data at height, but then there is missing data at weight in the middle of the data set, what happens?
It will ignore. It will not correlate that particular individual.
All right.
Yeah, so it's like you're saying inside there, katikati, one person had given their height but not weight. That's what you're saying.
That's what I'm saying.
It should give you an N of minus that person. It will run statistics on probably 8 of them.
Okay.
Or 9 of them. So they'll eliminate that person. So now to analyze, you go to analyze. Now you scroll down to correlate. Can you see correlate somewhere? Then we're going to do a bivariate. So we've said that we are looking at height and weight. Just move this to. And
then?
So now let's just look at that box and see what it is telling you before you click on anything. You can see the first check mark there is on Pearson's.
Pearson.
I remember I told you there are different kinds. So you can see even there are different ones like Kendall's and Spearman. And then below that it's saying test of significance.
Two-tailed and one-tailed.
Two-tailed and one-tailed. I can't describe that accurately for now, but just know it normally prefers two-tailed. And it's also asking you to check to flag for significant correlations. I'll show you what that means when you're interpreting the data. Okay, so just click. So now it has generated that particular data set for you there that you're seeing. It's a box of correlations. You can see it has the variables. Can you see that height and weight? Height and weight are appearing both column-wise and row-wise. You
can see that.
That's the first thing. That's the thing that I want you to understand first of all, is that a correlation runs both your variables and puts them in a table, both row-wise and column-wise. Okay. So it actually correlates variables against themselves. Those rows and columns intersect. Okay. Where there are intersections, that is where the results are for the correlation. Okay. And where a variable has intersected with itself, we normally say that's a perfect correlation, meaning you get a 1. Okay. A positive 1 rather. Well, can you see where weight and weight is intersecting and where height and height is intersecting, there's a 1.
Weight and height, weight.
No, now, first of all, look at weight and weight and height and height.
Yeah, I can see that.
Where weight is meeting weight, it is a 1. Where height is meeting height, it is also a 1. So when something is relating to itself, of course, it is a perfect correlation. So that's why it's a positive one. Okay. Now when you're looking at the first column on the left, one's in gray, it's trying, SPSS is telling you what those values are. So the first thing is showing you is the Pearson correlation value. That is in other books or somewhere else, they might call it R. That's the R value. That's the Pearson correlation value. You can see with the weights, the first one, as I was indicating, is a positive one. And when weight and height intersect, it's 5.574. Remember, we had said that value must be between -1 and a +1.
And 1.
Can you see that's the case? Is it obeying that case? Yeah.
It is. So that means there's a correlation, a positive correlation.
So very good, you're interpreting the value. It means that it's a positive value. So first of all, it means that there's a positive correlation between weight and height. Okay. Below the
So when
Pearson
it's a positive correlation, I was probably gonna ask the same thing that you're gonna tell me. Does that mean that when one value goes up, the other one goes up as well?
That's true. Remember,
That's
I
what it
told you to
means.
describe even.
Okay.
Remember, I told you the correlation in a layman's way is how things are moving, whether they are moving together or not. So yes, when you say positive, it actually means when it's a positive correlation, it means when one is going up, the other one is also going up. So
I just want to check the data set again.
you are confirming whether height is increasing, the rate is increasing.
From what I can see, it's more or less true. Not 100%, but in most cases, yes.
Remember also we could remember very, very first lesson, I think I showed you can sort based on ascending or descending rather than checking manually your search. Remember that?
Remember you telling me?
I think is it showing me?
Still more or less accurate. Yeah.
So now that 0.574, that's that is the correlation, the R value.
Where did it go?
Yeah, that's look for the output file. It should be on the desktop. When you go down, not even just where you're opening the SPSS. Good. Just minimize. Oh, not even that. Can you see where your apps are down? You see when you open the app where it's normally there down. Yeah, there. Right there. So I was saying you have those, it's a positive correlation. The next value known as a SIG, the SIG two-tailed, Sig is just short for significance. Okay. Sig is short for significance. So in this particular case, it's trying to tell you, you see, you can have a relationship between two variables, but it's not a given that the relationship is significant. Two things can be related, but it doesn't mean anything.
Oh, really?
So that sig value is, or it's telling it's not strong enough to mean anything. You see, when you've checked the data and you've seen, oh, they're actually moving together, but are they, is that data sufficient to actually, for you to say that, now I understand something? No, it's not always a given. That's the purpose of that particular output there, known as sig. And in interpreting it, we normally base it on a level, a particular level, which is 0.05. If that value is less than 0.05, then it is significant. If it's more
if it's less than 0.05, then it's significant.
Yeah. If it's less than 0.05, then it's significant. If it's more than, then it is not.
So in this case, it's not significant.
Exactly. In this case, it's not significant. Oh, why do you say it makes sense?
It makes sense because the correlation itself, when you look at the values, even though there's a positive correlation, it doesn't apply to all the variables.
But the actual reason why SPSS is telling you this is not significant is because your sample size is too small. Okay? Your data is very few individuals. When you're running, remember, I forgot to tell you, but when you're doing a correlation, falls under a broader category of statistics known as inferential statistics. The ones we were doing before, the mean standard deviation, those are just descriptive statistics. Those ones are key, and you don't even test for technically you don't test for the significance of descriptive statistics because they are what they are. The mean is what it is. The average, it is what it is. But now when you're trying to infer something, to check for the relationship, it's very important to note whether what you're doing is significant or not. So in one of the criteria for knowing whether something is significant is how large is your sample size. When you have a sample size of only 10, in most statistics, you're told it's normally not significant. You need at least 30 going higher. Something to register significant. So just know that the likelihood that it's not significant is because the sample size is small. The other thing I want you to notice is that it has given you the n. So as you can see, it's just the data where you had values. So it ignored the missing data. The other thing is you can see it is repeated, the 0.574. You can see it's repeated because you're correlating the same things. I don't know if you can notice that.
Because it's still height and weight either way, right?
Yeah. Because it's still height and weight, it's giving you the same values. But now I want us to run, you can correlate more than 2 variables. So I want us to actually go back and add the gender and see what happens. You don't even need to click out. Remember, I told you when you're analyzing, from wherever you are, you can just go to analyze. Doesn't matter.
Right.
That option is always there. So now go back to analyze and then correlate. And then bivariate. And then now we move the gender there. All those just remain the same. And then just say okay. So now you see it has added the gender both column-wise and row-wise.
Mm.
And you can see there, and now the values are even changing. You're having negative values. It now has some asterisks on some of the values. So again, what do those mean? So in this particular one, first of all, I wanted to see the height and weight have remained the same. They have not changed just because we introduced a new variable. They are still the same. But now we have negative values like the weight and the gender, right? So just like we were saying in the other one, that if it's positive, it means they move. If one is moving up, the other one is also moving up. So in this particular case, between weight and gender, then they are moving in opposite directions. It's a negative correlation. If one's moving up, the other one is moving down. Okay. That is what it means when you have a negative correlation value. So, and then they are both negative for both weight and gender and height and gender. You can see that.
You can see what? Sorry? That
They are
they're
both
both
negative. Like
the
correlation between weight and height, as well as gender and height. So weight and gender and height. But they are both negative, meaning they both move in the opposite direction. Now, the correlation between weight and gender, it has asterisks on top of it, those two stars there. First of all, that particular, whenever you get an asterisk, it's like a SPSS, it's just trying to, it's bringing your attention to it. It's calling out that data for you to look at it. Okay. So in essence, what it's trying to tell you is that that particular data is significant.
It's sorry, that the data is
significant. So even when you now look at the sig value, can you see what it is?
0.58, no, 0.09.
I want you to see, can you see where weight and gender are correlated? That's where you have the asterisks. And I've told you SPSS is calling out your attention to that point. It's trying to tell you this data is significant. So even when you look at the sig value for that data, the 0.09, it's actually less than 0.05, meaning that it is actually significant.
So that means the correlation itself is significant.
Yes. It means
What does that mean?
gender actually does. It means if you are considering between the correlation between height and weight is not as significant, but that one between gender and weight. Okay. You should pay more attention to that.
But in this case, is it accurate because the data for gender is nominal? is it really significant?
That's the thing. So someone else might dismiss it based on the type of data you have. Whatever you're saying is accurate. It's correct. It doesn't make sense since the type of data is not the same. So it is not. But if you really have to give an interpretation, that's just what SPSS is trying to tell you.
I see.
If you really
Wait,
must
was
interpret
one coded for male, right? And 2 for female.
Yes.
So this means that if weight, no, it doesn't make sense. Let's see,
what are you
just a
trying
second.
to?
I was trying to see here if for male, I can see the values for male for weight is higher than for female. Like when you have the ones, you have the 138, 144, 158, but when you have the 2s, the weight is lower.
For male or for me female?
For female.
2 is female.
2 is female. So female have a lower weight compared to the male. So I was trying to see how now this interprets it. So if it's a negative correlation, you said that if one goes up, the other one is
yes. Telling you as you move from males to females, correct? That's what it's checking. As you're moving from males to females, then the height is going down. That's correct, actually.
The weight is.
You see, it's actually correct. Because it's just 1 and 2. So it's checking as I'm moving from 1 to 2. How is that impacting the height or the weight? And it's telling you it's impacting it negatively. So it's telling you as I'm moving from males to females, the weight is going down as well as the height.
Okay, makes sense.
Yeah, so it's actually correct. It's exactly how you've seen it when you looked at it. So, but it's just telling you also that movement, it's more impactful on the weight as opposed to the height. That's the other thing that it's adding when it now puts the asterisk on the correlation between gender and weight. That's the other thing that's also adding there. What else? That is the checking for statistics and significance. And then now you can see in the, actually there in the end, it is considering. I've just noticed that it's considering even the absent.
The absent data.
Yeah, the absent data. Although there was literally no data. There was data there was gender, but there was none for height and weight. It was actually considered. That's interesting.
That's it's because we have data for gender.
It has data for gender. So I guess if there is one data provided, it will actually consider.
Interesting.
Yeah. So,
but so this means that the results have error.
I'm not sure I can interpret it like that. As opposed to error, it probably substituted with 0. That's my assumption.
But doesn't that impact the whole correlation?
It probably does. So whatever you're saying is correct. There's probably error because it has substituted something for 0.
Okay, that's
so
not
in that particular case, what that tells you, even when you are collecting your data, you should take care of missing values first, that you do not end up adding error to your analysis. But I can see it actually considers the missing. So the other thing in the correlation, you can also do a diagram, which is known as a scatter plot. Let me show you that one. Yeah, you go to, now you don't go to analyze, go to graphs, chart builder. Is it telling you? Before you use this diagram. You press OK to define your chart. Set measurement level or define value labels. We had not defined, I thought we had defined the value.
Defined what?
I think it's like saying, or maybe it's like trying to tell you you cannot correlate gender or. I would just click define variables property.
Sorry, what did you say?
Yeah, but you've already clicked this. I wanted you to click the define variables. I see what it had a problem with. Just you can close and click again.
So I go back to
graphs.
And then I go here.
Click define. Yeah. Saying what? Use this facility and set other properties of the sign. They should be categorical, nominal. I'm not sure what it wants you to do, honestly.
So we just proceed.
Just proceed. Say okay. So I was saying you can do a scatter plot. So it gives you different options, but we want a scatter plot. So actually when you we've even selected. So when you put your cursor on top of those two images, it should tell you what kind. Okay. Simple scatter. Flat line. So I don't know. Maybe we do the one with the flat line. So now you'll pick it and then you drag it to. And then you're going to take, now what do we want on the X? What do we want on the Y? Let's put height on the X.
Height on X. And then weight
on Y. Is there anything else? I think you should just click. I don't think there's anything else.
Okay, it disappeared. Oh, here it is.
There's nothing. Oh, thank you. So you can see it's trying to, you see now, I don't know, I think you can even see why it was telling you it's not significant. Can you see?
I can see.
You see, technically speaking, most of them are farther away from the line. Yes, they're moving up. When one moves up, the other one moves up, but not that much. That's what it's showing you.
So if it was a positive correlation, maybe of 1, they would all be here on this line. The dots, all the dots would be on the line. And if it was a negative,
exactly. If it's a positive, it's a negative, the line would be facing the other way. It will be moving down.
It will be like this.
It will exactly
like this, but then the dots will still be on the line. It was a negative
if it's
1.
a perfect negative. It's a perfect negative. They will all be on the line. Yes. So this one is showing you that it says it's a positive correlation, but it is not that strong because they are a bit far from the line. So the stronger the correlation, the closer they will be to that particular line. Oh, I don't know. Do you want to try and test with the gender? See what it shows us.
Sure.
Okay. But you'd have to remove the one of them. You get? No, put there. Oh, you've already. Let's just see. What? I can't
What
even
is
see.
this?
It is like.
Okay.
I would have preferred. I wanted you to put the gender on the X. I struggle
Okay,
to
let's do
understand.
that.
Now remember, it's still on the Y, so just remove all that. Now say
What? What does this even mean?
but now
did I
you see there's
select?
1 and 2 on the. No, it's okay. That's how it should look.
Oh, this is how it should look.
Because you see, there is the 1 and 2. You see, that's the issue with this data. It's just 2 variables on the. It's just 2 numbers.
So
and
how
then
do you analyze now the correlation on this graph?
First of all, so it has not shown us the direction. It can't even see the direction. This one is for height. Going to try and do for weight. You see, that will give us the direction. Now put it on the Y. Put it on the Y first to see. Why is it telling you now? Oh, it can add actually more than 1.
It has to, but I wanted to add 1. So, but it's okay if the dots will have different colors.
Just put. Let's see.
Oh gosh.
That data is too little to understand. Why? Yeah, I guess it's because of the size of the data. And given that gender is just 1 and 2. There it's better interpreted with the box that we got very initially. Show that there's a negative. It's difficult to see. So that's another thing you should just know. The more your data, the more data you have technically, the better, the richer your analysis would be. The less it is, the more it's not clear to see. Oh. Okay. So that is That is, most correlations are normally denoted by such a scatter plot. So if you add more data, it will be much more clear. So if you're doing that, and as you said, that's what you'll be pressing. You can choose those different types of scatter plots to see.
And now these other ones, how do you even analyze them? They look a bit complicated.
Yeah, they do. Yes, they do.
Like this
That's
one is
why you don't
like a box.
in it's 3D. But you can try. You want to try? You can just pick any and just see. See, and do for height and weight. Otherwise, it will confuse us. You've picked which one?
I had picked the 3D one.
I don't think you've picked any. Just do go back. Pick and drag it there. You have to drag it always. You want to do gender still?
Let's try this.
Huh? Is it refusing?
Yeah, it's refusing. The Z axis. Why do we need to have a Z axis?
Because it's 3D. Oh, 3D is for data. There's some data that normally requires more than. I would just throw in gender, we see what it will do. It requires more than one data to plot a 3D.
It's refusing.
It's refusing. It's refusing that gender that can't be our Z axis.
Okay, so
oh God.
I don't know. Then here we have filter.
Yeah. But 3D scatter plots, actually, you might have more than one, more than two variables that you want to see how they will relate.
Maybe they all have to be. They all have to be ordinal, not ordinal.
Like checking something like this. Maybe you're checking how far did you go. How fast did you accelerate in a given distance? And you also want to see the time taken. And you see that will be possible in a 3D dimension. You get?
So here you have the
speed,
distance, you have
and time.
Speed and time. I see.
You see that will work. That's for such kind of data. So in this particular case, I guess it has. If it's in gender, no way we can do 1 and 2 for that. Yeah. But
all right, but I think I got it for correlation.
I would prefer you just stick to that scatter plot with a line. That one would be easier to interpret. So that's the basics of a correlation. I don't think there's anything else for you to know. If you're doing one very base, just know that if you want to do a correlation, you go to analyze, and correlate, and then bivariate. Bivariate just means you have two variables.
Let me ask you, does SPSS do a summary for you after you have analyzed data?
Do? Does SPSS do?
Summary. Is there anywhere you can find the summary of the analysis that you've run? Let's say if you've done various analysis, or you have to be the one typing on the site.
I don't think it summarizes for you. See, technically, but when it does analysis, the very first thing it gives you is essentially a summary. Then it goes down into more detail. But I don't think it summarizes. You can copy. Even those tables and graphs, you can copy.
Oh, I see. Perfect.
See? Okay. Yeah. You can copy them even into Word. or even Excel for the tables.
That's good.
I'll show you.
All right.
So next time, I think we'll reach there for now and continue with some more complex analysis next time.
Cool, no problem.